Characteristics of parabola. In this lesson, we will learn the characteristics of parabola. We will be able to determine the axis of symmetry and vertex of parabolas from graphs, and then determine x and y intercepts of parabolas from graph, then find the direction a parabola opens and its axis of symmetry and the vertex form from the general form of its equation. And then finally, identify the axis of symmetry and vertex of a parabola from its equation and standard form. Now what you see here is a graph of a quadratic function called a parabola. The one important feature of the graph is that it has its extreme point called the vertex. This is an example of a parabola that opens upward. The vertex is the minimum value of the graph. If you have a parabola that opens downwards, the vertex will be the highest point or the maximum point. Now, these 2 points here are called the x-intercepts. These are the intersections of your parabola at the x-axis. So not all graphs will intersect at the x-axis. Sometimes its vertex is on the x-axis, so it will only have one intersection point, and that is also the vertex. And this point here is the y-intercept. That is the intersection of the graph on the x-axis. And this line here is called the axis of symmetry, and this line here passes through the vertex. At the axis of symmetry, the graph of your parabola is symmetric with respect to the line, this line here. That means it mirrors through this line here. The graph here is exactly the same as this graph here. Or if you fold the graph along this line here, this curve here will intersect with this curve here. For example, determine the vertex and axis of symmetry of the parabola shown below. This graph here is the graph of this equation, y equal to x squared minus 2x minus 3. The vertex is the lowest point of this graph, and this is this point here. So this vertex here, or this point here, has an x coordinate equal to 1, and the y coordinate is negative 4. So the vertex is the point 1, negative 4. Now, because this parabola opens upward, the axis of symmetry is this line here, and it passes through the vertex. It's a vertical line that intersects the parabola at the vertex. And the equation of that line is x is equal to 1. Now let's consider another example. Determine the vertex and axis of symmetry of the parabola shown below. We have here a parabola that opens upward. The vertex is the lowest point of the parabola, and that is the point 1, negative 9. Now the axis of symmetry in this case is a vertical line that passes through the vertex. So it is this line here that passes through x equals 1. And since it's a vertical line, the equation for a vertical line is of the form x equals a constant. So the axis of symmetry here is the line x equals negative 1. Now the y-intercept is the point at which the parabola crosses the y-axis, and similarly the x-intercepts are also the points at which the parabola crosses the x-axis. Now if they exist, the x-intercepts represents the zeros or roots of quadratic function. That is the values of x at which y is equal to 0. For example, find the zeros and y-intercept of the graph shown here. The zeros are the values of x at which the graph crosses the x-axis. So in this case, these are the points. These two are the zeros of our parabola, and that is x equals -2 and x is equal to 4. Now the y-intercept is the intersection of the graph at the y-axis. So it is this point here where y is equal to -8, and that corresponds to the ordered pair 0, x equals 0, and y equals -8. So the ordered pair 0, -8. Another example, find the zeros and y-intercept of the graph shown below. We have here a parabola, and this is the graph of the equation y equal to x squared minus 2x minus 3. The zeros are the intersection of the graph at the x-axis. In this case, it is x equal to -1 and x is equal to 3. And the y-intercept is the intersection of the graph at the y-axis. This case, it is y equal to -3, and that corresponds to the ordered pair 0, -3. Now the general form of a quadratic function is given by this expression here, f of x equal to ax squared plus bx plus c, where a, b, and c are real numbers, and a, or the coefficient of x squared, must not be equal to 0. Now there are key features of a parabola that you can get by just looking at the equation of the parabola. So if you are looking at the equation of the parabola and the coefficient of x squared is negative, that is less than 0, then we have a parabola that opens downward. Similarly, if a is positive or greater than 0, we have a parabola that opens upward. And we can also use the general form of a parabola to find the equation for the axis of symmetry. In general, the axis of symmetry is defined by the equation x equal to -b over 2a. Again, b here is the coefficient of x, and a is the coefficient of x squared. And we could also use the quadratic formula given by this equation here. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. This is the formula that we can use to solve for this given equation here, or to solve for the zeros of our quadratic function, or the zeros or the x-intercept of the parabola. For example, consider the given figure here. The figure here, it represents the graph of the quadratic function given by y equal to x squared plus 4x plus 3. Looking at the coefficients of x squared, we say that a is equal to 1, and the coefficient of x is 4, so therefore b is equal to 4, and c is equal to 3, that is the constant. Now, since a is greater than 0, that also verifies the graph of the parabola here that opens upward. And the axis of symmetry, if you look at the graph, the axis of symmetry is this line here, and this line here passes through the point x equals -2, and that is the x-coordinate of your vertex. So the axis of symmetry is usually the x-coordinate of your vertex, x equal to -2. That's the x-coordinate of your vertex if you have a parabola that opens either upward or downward. the axis of symmetry is x equal to the x-coordinate of the vertex. So this also makes sense because we can see from the graph that the vertical line x equals -2 divides the graph in half. And we also see from our examples that the vertex always occurs along the axis of symmetry. Now also, for a parabola that opens upward, the vertex occurs at the lowest point on the graph. In this case, for instance, it is the point -2, -1. Now, if we have a parabola that opens downward, the vertex occurs at the highest point on the graph. Now, the x-intercepts are those points at which the parabola crosses the x-axis. In this case, we have our x-intercept is x equals -3 and x equals -1, or those are the points that corresponds to the ordered pair -3, 0 and -1, 0. So in general, a quadratic function is a polynomial function of degree 2. It is of this form here, f of x equal to ax squared plus bx plus c, and its graph is a parabola. Now, the vertex of the parabola, we will denote that as hk, can be computed as h equal to -b/2a. This was just our line of symmetry, axis of symmetry. And the y-coordinate is just the value of the given function evaluated at the point x equals -b/2a. So therefore, if you are given a quadratic function in general form, to find the vertex of the parabola, you first have to identify the coefficients a, b, and c, and then find the x-coordinate of the vertex using the formula h equal to -b/2a. Note that this is also the axis of symmetry. And then you find k, that's the y-coordinate of the vertex, by evaluating the function here, f of x, so at the given value of h. So evaluate f of -b/2a. That is the y-coordinate of the vertex. So for example, given the function here, f of x equal to x squared minus 3x plus 12, determine the direction in which a parabola sketching its function would open. Now looking at the coefficient of x squared, a here is equal to 1, and that is a positive number. So if a is greater than 0, we know that we have a parabola that opens upward. Now in this example here, we are given the quadratic function f of x equal to x squared minus 8x plus 12. We are to find the axis of symmetry and the vertex of the function. To do that, we first determine the coefficients of x squared, x, and the constant. So that is, determine the values for a, b, and c. A is equal to 1 in this case, that is the coefficient of x squared, and b is the coefficient of x, and that is equal to -8. And the axis of symmetry is given by this formula here, -b/2a. All you need to do is plug in to that formula. So replace b by -8, therefore you have negative of -8 in your numerator, and then divide that by 2 times a is equal to 1. Simplifying this will give you 8 over 2, and that is x is equal to 4. That is our axis of symmetry. Now, and then to find the vertex, we can use the axis of symmetry, that is the x-coordinate of the vertex of our parabola, because the axis of symmetry runs through the vertex. So therefore, the value is also the x-coordinate of the vertex. Then now we are to find the y-coordinate of the vertex. To do that, we just need to plug in this value to our function f of x equal to x squared minus 8x plus 12. So we will replace x by 4, that is the x-coordinate of your vertex. So we have 4 squared, that is your x squared, negative 8 times 4 plus 12. Simplifying that will give us negative 4. Therefore, the coordinates of the vertex of the parabola are 4, negative 4. So alternatively, the quadratic function may also be written in this form here. F of x equal to a quantity x minus h squared plus k. This is what we call the standard form of the quadratic function, where h of k here is the vertex. This can be derived from the formula f of x equal to ax squared plus bx plus c by completing the square method. So now if you're able to write your quadratic function in this form, you can just immediately get the value here or equate this term here or expression to 0, solve for x. That would be the x-coordinate of your vertex. And the value here will be the y-coordinate of the vertex. And again, in general, this a here, that's the coefficient of the leading term a, would tell us if we have a parabola that opens upward or downward. So if a is greater than 0, the parabola opens upward, and then the vertex is a minimum. And similarly, if a is negative or less than 0, the graph is a parabola that opens downward, and the vertex is a maximum. Now let us consider this example. We are given a quadratic function in the standard form, and that is y equal to negative 3 times quantity x plus 2 squared plus 4. Looking at the equation here, we can equate this expression to x minus h, so we could solve for h. And in this case, h is just equal to negative 2. Or what you can also do is to get this expression here and equate that to 0, solve for x. That would be the x-coordinate of the vertex. Now also, it is important to take note that a here is negative, and if a is negative, the graph of the parabola opens downward, and that could also be verified by the graph here. We have here a parabola that opens downward. Now, if the parabola opens downward, the vertex of the parabola is at the maximum point or the highest level. Another example, the graph of the function negative 2 times x minus 3 squared plus 12 will be a parabola opening in which direction? So all you need to do is look at a. In this case, a is equal to negative 2. That is negative, so therefore we have a parabola that opens downward. Now, using the same given function, we want to find the axis of symmetry and the vertex. So to get the axis of symmetry, all you need to do is get this expression here and equate that to 0. So you can have x minus 3 is equal to 0, and then you solve for x. X therefore is equal to 3. That is the x-coordinate of the vertex, and that is also the axis of symmetry. Now, to get the y-coordinate of the vertex, you are going to just get this value here. This value here is the y-coordinate of the, so this value here is the y-coordinate of the vertex of the parabola. Hence, the coordinates of the vertex are 3, 12.